Are we live? Are we live? I am seeing it. We are live officially. Trying to make sure that,
Nice.
yes. All right, cool. So today we're going to be talking about ZenML and Metaflow, aka Outer Bounds if you're paying for it. The big thing, though, that we wanted to start off the conversation with was what we were just talking about. And Ben has some spicy takes, semi-spicy, mild, lukewarm takes on if you even need a tool like Metaflow or ZenML, since there are tools like Modal out there. What's the argument there?
I would say that I would say this is such a lukewarm take, but the argument would be that if you have a tool like Prefect and you're orchestrating all of your workflows such that they're just regular Python code and there's no like DSL around it, and then you're able to get the compute either through Prefect or through Modal. And I don't know that Modal is super critical in that regard, but like if you can schedule all of it in Modal, I guess getting like GPUs make it's really easy to get the GPUs to do training. Um, the value of those tools is a little bit less because it's pretty easy to handle all the checkpointing and all of the caching and all of the retrying just built into
Mhm.
Prefect, which is a broad generic tool. Um, like if I'm going to have one tool, if you're just trying to solve problems and the problem is I want things to run either at a cadence or at some event, and I don't want to deal with as many tools as I need to deal with, like just one tool, Prefect can certainly handle all of them. And it can also do things that aren't ML focused, like I use Prefect to like send automated emails, and I use Prefect to train
Uh,
my models. I also, when I'm training those models, track everything in weights and biases, and checkpoint the models at different points in time. So like, there's a lot. You just have broad Python if you can just orchestrate Python in a really easy way, and you have like one system architect in your team. I think it becomes a lot easier to do that.
so it's almost like an unbundling in a way, because, or it's a detaching from this specific vertical need of being that ML use case and saying, let's just use a more generalized tool with the compute engine.
Yeah, and I think that the response people will say is like, okay, but you now have to worry about checkpointing your data and also checkpointing like your model at every step and making, like Metaflow has some new features which are very cool around like freezing your model at every step and like being able to checkpoint it at every part of that process so that you can always reproduce, which is very cool. Like it's definitely valuable. But if the tool can't also do all your data processing, like I don't know how many DAG tools I want in my stack. I
Uh-huh.
bias towards simple rather than
Yeah.
complex.
Yeah.
But I know Eric disagrees with me.
I don't know. Like, I don't think I disagree. I just think I haven't seen someone do this yet with Modal. I've seen the dedicated DAG tools for data science be successful. I've never used Modal at work. And so I just I can imagine so many things already that I would do differently if I were using Modal. And so it's just such a different way of working. I don't know. I think I just need to be shown, honestly.
Well,
The guy that I wrote for running prefect jobs on Modal with a Modal like serverless push pull is on their official documentation now. Maybe we'll walk through it.
we
Uh,
need to
it's
give
pretty
you a
easy.
medal for that because I know you're very proud. I'm gonna send. Did you get the cookies I sent you
Sure.
in the mail?
I'll take them if you're sending them.
That's right. So the thing that I'm fascinated by on this is trying to figure out how much can be generalized and how much can should be specialized. I know that with Metaflow, back when they came out, they have the coolest visual for who they are targeting and why
Yes.
use Metaflow, and it's like that those two pyramids, and maybe somebody can pull it up. It's
I'm
basically
looking for it.
what data scientists want to be doing or what they care about versus what you have to do to get the model in production type thing. And so
Yeah.
Metaflow connects those, and which makes me automatically think that, okay, Metaflow is a tool for data scientists specifically. In your experience using it, Eric, is that kind of in line? Has it evolved since then?
Oh yeah, it is. Here's the visual.
All right, let me pull that up real fast. Yeah, exactly. How much data scientists care versus how much infrastructure is needed.
Yeah,
Which
Okay,
this
wait.
is
I
great.
totally
Yeah,
don't agree with. I don't agree with this picture at all. You think data
Okay.
scientists don't care about data? What does
Yeah,
that
now
mean?
that I look at it too, I'm like, wait a minute.
I feel like data is literally the top of that. Am I reading it backwards?
No,
Data
no,
I
scientists
no.
feel
care.
like I feel like data here is like, yes, data scientists care a lot about data, but there are bits about data they don't care about. Like if you ask the data scientist about like ingest and transformation and like data modeling, they probably care about those things the least, like
Uh-huh.
things that a data engineer would do. But they do care about getting the insights from the data. So I don't know. I feel like you could almost split this out into two boxes, like data ingest versus data reading, and you could put data reading like right under modeling or something.
Yeah, it's almost like modeling gets confused with that data part of figuring out the insights from the data versus just cleaning the data or getting the data from one place to another or the ingest. I could see that. But it is weird how they phrase it now. And maybe when I first saw it back in the day, I was too naive to realize, like, wait a minute, data? Data scientists don't care about data. It's literally in their job title name.
If Savin and Mila are watching the stream, I wonder what they're thinking. Like,
Yeah.
because I'm positive they agree with our interpretation of this. That like data, there's a version of data that goes up here closer to modeling. Like,
Yeah.
um,
Yeah, it's just a different type of data. So anyway, getting back to the original question, like data scientists, outer bounds slash ML flow is made for data scientists, and is ZenML that same way? Have in your experience, like what have you found in working with it, with both of them?
yeah, I think they are very similar tools that serve very similar people. Actually, I think we kind of just jumped straight into like modal and ZML and out of bounds. I have some slides to like frame where all this fits in. Let me like
Oh,
set some
nice.
context. Oh wow, I
Oh, nice.
literally even had this in my slides. I forgot about
Dude.
this. Okay,
Dude,
okay, okay, okay.
you did some homework. I appreciate the dedication here.
Thanks. Okay, like quick story. This is the story of my first job. So I joined at this company, and this was in 2018. And even then, even in 2018, MLOps was newer than it is today. Like,
Yeah.
but very new. Like, I feel like that was the year it started being used as a term on LinkedIn everywhere. So, um, and so like right and left in Utah where I live, like data science teams were failing. Like I had friends who were just going, they were going from like layoff to layoff to layoff, like across all these companies because there was like the hype cycle. Like the company would
Yeah.
be really excited about ML, and then they'd hire a team of researchers, and they didn't know what they were looking for, so they were like, let's just get PhDs. Like those are the people who know what to do with ML, and then we'll
Set
just
up
give
the
them a bunch of
pattern.
resources, and they'll make money for us. like, um, which like
Oof.
does I don't know if we like the AI hype world. Does that not sound kind of familiar to like are we not just doing that again? I guarantee you we're doing that again. like anyway, so so we had this like the product I was working on at the time, it was a Chrome extension to help sales reps use Salesforce. So like you would install this Chrome extension and you'd open up salesforce.com and it would show you all your contacts and it would like inject a bunch of like extra analytics like alongside all your contacts in your list. And so like what there was this feature we were working on, it was literally like how likely is someone to respond when you contact them. It was a score, and
Oh,
it was
nice.
a number between 1 and 100, and I don't know what the like to this day I don't really know what the number meant. Like higher was better basically, and like um and so the goal was we had this Chrome extension and we wanted to show that number in Salesforce.com. How likely is someone to call you back? And it took us 18 months to get that number into the UI. Like, and like by the time we got it into the UI, I mean, so, like one of the questions I just raised came up. It was like, is this valuable? Like, do people actually use this? Like, let's say someone had the number, what would they do with it? Like, if someone gets the number, do they know why the number is that way? Like, why is the number high? Is it because if I text this person, they'll answer me? If I email them, they'll answer me? Like, if we start talking, like, do I expect the conversation to go well? Like, anyway, like, there's a lot that one number didn't communicate, and that was a common theme back then too. Like, don't just show numbers to people, like give them explanations of where they came from. Anyway, so a whole bunch of things that, and we did everything wrong. And one of the things we did wrong was how we structured our teams. So like we had like this data science team and we had this data engineering team, and I was on the data engineering team, and I was just excited to have a chance to work with anything data sciencey too, because like I had wanted to be a data scientist. Anyway, so we did the handoff model. So like the data scientists, they trained a random forest model in scikit-learn, and they had a pickle, and they sent the data engineers the pickle, and they said, here's your model, like get this in prod. Oh, and it was a little more complex because we had like different customers, and each customer we would train them their own pickle. So, but that's not like that. That's not that much more complicated. Anyway, so then yeah, they said good luck, and then it was on the data engineers to know how to deploy this thing and monitor it and update it as well, because we owned it from then forward. And so I've seen this happen a lot. Like this is the dysfunctional relationship between data scientist teams and data engineering teams. So data scientist, hey, can you please turn this script into a data pipeline? Actually, can you update that pipeline? Actually, can you make the pipeline into an API? Can you do it again? We totally, like, we're not using random forest anymore. We're using SVM. How's it doing? What do you mean the output doesn't make sense? Explain why it's broken, and like how long has it been broken? Make this more performant. Okay. And then engineers on the other side, people who weren't familiar with like stats and modeling and stuff. Can you please document how this works? Can you please stop committing models and CSVs directly to Git? Can you please solve dependency hell for me? Stop bothering me. I have other teams to support. You explain why it's broken. You make this more performant. And like the reason I bolded these things is like, think about it for a second. Like what does it mean for something not to be performant? Does it mean it's not fast? It could. Does it mean it's like too resource hungry? It could mean that. Does it mean that like the quality of the inferences is bad, like the accuracy is low or something? It could also mean that. So like if it's like an accuracy data type question, maybe the data scientist should think about it. If it's like an infrastructure type question, maybe the engineer should think about it. Except sometimes you can save on resources by using a more efficient algorithm. So actually maybe resource management is more of a data science concern. Like, I don't know, there's like actually a lot of conversations that would need to go back and forth between these two groups if you want to solve those kinds of problems. So, and basically I think this is what happens if you throw something over the fence anytime. Like anytime you give a product to a group to own that they didn't create, like you're gonna have problems because they don't understand it as well. So anyway, so the idea was we could stop having data engineers deploy and maintain AI products, and we could make the data scientists do it. So so you could just hire data scientists who know everything, like every cloud, all the infrastructure as code tools, all the MLOps tools, the observability tools. Like you'll never find one person who's this much of a unicorn. I mean, they do exist, but they're really expensive. So anyway,
but yeah, the expectation is that data scientists should know that. That's funny.
I know. Like, well, I mean, if you don't want to do handoffs, like, let's say you wanted to consolidate it all into one team or one person, like, this is what could be involved. But yeah, like, anyway, I feel like we all talk about Stitch Fix as like Stitch Fix was the company they were pioneers in our time of MLOps. Like they had all these thought pieces that came out, and there's a whole bunch of like Stitch Fix articles.
Incredible articles from Stefan, who created Hamilton. He was, I think that is an amazing case of what you were just talking about, where they create an incredible data team and super advanced maturity. But then at the end of the day, did they create a product that was long lasting? And so it's interesting to think about that, but that's not exactly the theme of today, so I won't go down that rabbit hole, but it's fascinating, like how advanced that data team is. But just because you have an incredible MLOps team and an incredible MLOps process and all of that doesn't mean that you're going to have an incredible company.
Yeah, like what? Actually, I always wondered because I feel like I don't hear much about Stitch Fix anymore. Like, did they just not find product market fit? Do you know, or what happened to them?
I think it was so I don't know enough. I can't say for sure, but I just know that their stock isn't going so hot anymore, and so there was product market fit. Are they a public company? I should check that out. Somebody can fact check me in the chat. But Stitch Fix public. So yeah, they IPO'd in 2017, according to Gemini overview. So take that with a grain of salt.
Man, like, given how great their ML platform was, I mean, I would have invested, and it would have been a bad investment. So maybe I should rethink my whole.
The marketing, yeah, they marketed to us with the incredible engineering blog that they had.
Yes.
But
yeah.
Anyway, I derailed that. So what were you talking about, Stitch Fix?
Let's see. So, this problem of like handoffs are hard because you have these two groups who are good at different things, and so maybe you could consolidate them, but then you maybe have to make unicorns. So, so the CTO of Ben Labs, his name is Tyler Folkman. I think he's great, and I saw him posting some stuff on LinkedIn about that time, like in 2018, when I was working on that dysfunctional handoff relationship, and he sent me this link to the Stitch Fix article about how they think of platform teams. So here's like a blurb from it. So basically, this says that like data scientists enjoy working on vertical problems. Like if you talk to a data scientist about their work, you're probably going to have a conversation about a business problem, like how can we reduce customer churn, or how can we recommend the right things to people on Netflix, or what does that mean? Like they want to, like, if they're working on recommender systems, like they want to make the best recommender system that just like makes recommendations that like sing to people's hearts. And on the other hand, engineers, they usually, me at least, my eyes usually glaze over in those conversations. I'm like, I don't actually care about click-through rates. So like, or customer churn, or maybe sales in general. Even if I work in a sales company, like one of the reasons I became an engineer was like, because I like abstraction and making reusable things. Like I want to make the best tools. I mean, as an engineer, I also like working end to end, and I think data scientists do too. But I think as a general statement, I think data scientists like vertical problems, and that's where data science really lives. And then engineers often like horizontal problems, like reusable things. And so the thought was like, why don't we take, like here's the triangle, visualization that Outer Bounds made. Like, what if you took each of these triangles and made a team per triangle here? So maybe you have a team that only does data science and doesn't need to care about like compute and orchestration and versioning and deployment. And then you've got another team who cares about compute and orchestration and versioning and deployment, like such that modeling can be a fun, easy task. So like there's a big difference between building something from scratch and operating that thing. Like AWS Lambda is a platform of a sort. Like I can use AWS Lambda, but if you ask me to like get out Firecracker VM and Kubernetes and like create AWS Lambda from scratch, like I would struggle with that. But I can use AWS Lambda, and like similarly, like as a platform engineer, I can probably create a demo platform, which is a set of like tools and patterns and workflows that somebody else can follow to do modeling. And like I can put together tools and host the infra on AWS, and then data scientists can then go use that tool. So like in the platform model, instead of doing a handoff, like you have someone build the platform, and then you have other people using the platform in like a self-serve way. So if you did this, what platforms would allow you to do is they'd allow like the edge team, like the platform user team, to own everything from end to end, like including monitoring it and updating. Anyway, so that's I feel like I saw a post on LinkedIn that was like, DevOps is dead, like platform engineering is the future. And I saw people, I know, like and people have said that about MLOps too. Like MLOps is dead. The ML platform architecture is the future, and it's just like actually. I've seen a lot of like really experienced DevOps people get upset at the DevOps version of that statement because true DevOps was all about speeding up developers and making things more efficient. And like I think a real DevOps engineer, air quotes, would like they're really upset when people say that platform engineering fixes the flaws of DevOps because actually DevOps done right should have fixed the flaws of DevOps anyway. But now there's kind of been like a rebranding to platform teams, which is like maybe what DevOps should have been in the first place. And like one insight there, like a phrase I've started using a lot is MLOps is a practice, not a person, and DevOps is a practice, not a person. Like it's weird to hire a DevOps team or an MLOps team. Like what you want to do is hire data scientists and engineers and have them all practice MLOps. Like you can't just anyway. Because
whenever I see job postings that say we're looking for an MLOps engineer, I'm like, I think you're conflating two things here.
I know. Yeah. I mean, in my mind, there shouldn't be anything but a platform engineer. Like if your job is to come in and facilitate ops, then maybe you're a platform engineer. Like, or maybe that's how you should think of yourself. So
yeah. So basically, we got into this little deck of a rabbit hole because it was like, who are we serving? We now have come out the other side and said it's a little bit more complex than just who are we serving? Is it for data scientists? But despite that, it does feel like there are certain personas that gravitate towards these tools that we're about to look at, one being ZenML and the other being Metaflow. The users are primarily data scientists. The people that are implementing it are more of that platform persona.
Exactly. And like one time I talked to Hamza, the CTO at ZenML, and I was like, or it wasn't me, it was one of the data scientists where I work on this call, and he was like, who's your target customer? Is it the data scientist or the platform engineer? And Hamza said it's both, but Hamza said like, I want to be clear, like we treat the platform engineer as a first-class citizen with ZenML. And I thought that was cool. Because most I don't know, like because that shows they think of the platform engineer as like a first-class citizen or like a primary concept. And you see with their tool, like one of the things ZenML makes it really easy to do is like platform engineers who have strong opinions about infrastructure, ZenML helps that, like it doesn't force them to change those opinions. Like it's a very flexible tool. I guess we can talk more about that later, but like maybe I can wrap it up with saying like this black box here, this is a platform. And if you have a platform, it would be built by a platform team and it would be used by like a consuming team. And so the question is like, what goes inside the platform? And the reason I brought all this up is because ZenML and Outer Bounds could go inside the platform. So like, I think I'll skip. But like, there's this MAD diagram that like has all the tools. There's a whole bunch of tools. There's tons and tons of tools, and like this is overwhelming to people. And one day when I was like thinking about ML platforms and surfing the web, I found the ZenML docs, and on their site they had this table of basically 13 or so jobs to be done in MLOps by tools. And I really like this because like this table, like every row on this table is a single job to be done, like a problem to be solved.
Make it a little bit bigger.
I can't really, but it almost doesn't matter. Like,
yeah.
I guess the point here is that like there are jobs to be done, I guess, and you can think of it that way. Like,
you don't have the link, do you? Or I'll find the link. What is it? ZenML docs?
Yes, if you go to docs.zenml.io, and then I'll show you on the sidebar. You've got, where is it here? The ZenML docs are amazing, by the way. Like when we go into pros and cons of ZenML versus Outer Bounds, ZenML wins as far as docs.
Wow.
Let's see. Oh man, they
changed it. Now they're not.
I know they've probably like it's honestly probably better, but like it's different from when I last looked at it.
It's all right. You keep going. I'll find it while you're doing it.
Let me give it like one more. Let's see, deploying ZenML. Hamza, what did you do? I'm just kidding. All right.
If
So
Hamza is watching right now. Oh, he is. It says at the top. At the top.
oh, nice. Wait, in stacks? Is that what
Where
it
it
is?
says stack.
Oh, it is.
Yeah.
Wow. Okay. They gave it. I was like, this is the single biggest concept in ZenML. Like, I was like, how could they have hidden this?
All
Okay.
right.
Each of these things on the sidebar here is like a different. You know what? How about I actually finish the slides?
Yeah.
Like,
Yeah.
and then this will
Cool.
make anyway. So
I'll
jobs
drop
to be
the
done.
link into the chat though for folks if they want to see.
Nice. Okay, so I made this like very genericized architecture diagram after I saw this of like if you had one tool for each job to be done, each row here, then this diagram on the right is like an architecture diagram of how those tools would like interact with each other. So it's too small, so don't worry about reading any of the text. But like down here is a laptop. So this is my laptop, and I'm a data scientist. If I want to train models, or if I want to do any sort of like long running big compute from my laptop, I need somewhere to send that. Like if I want to kick off like a training job for a deep learning model, like maybe it's distributed, maybe it's not, maybe it's single node. Or if I want to do like a batch inference, like load up a trained model and then use it on a bunch of data, like I'll also need compute for that. So you need somewhere to get big amounts of compute. And when you do training jobs and batch inference jobs, you don't need the compute to necessarily spin up super quickly. I mean, it's convenient if it spins up quickly for cycle time for development, but it's okay if it doesn't. The main thing is that eventually it does spin up and you get it. Whereas like if you want to serve an endpoint, you do need like latency to be fast, and you need the compute to like always be there and be highly available and all that. So like you might have a different kind of, this box out here is supposed to be like online inference compute, which is maybe different. And then here's a bunch of data stores in the middle. Like where do you put your code? Where do you put your experiment results? Where do you put your features, both online and offline, stuff like that. Anyway, so you could think of this whole generic architecture diagram as a stack, an MLOps, like an ML platform stack, basically. And it's kind of like a full stack app. Like every full stack app has some database, some backend API, and then some front end. This is the same concept. Like every ML platform will have some sort of like offline compute, some sort of feature store, some sort of code repository, and then like a couple other things like after that. Like those three things I just said, that's like the minimal MLOps stack, but then you can like add more optional components depending on if you actually need like endpoints and stuff. Anyway, so the docs of ZenML, that's like if you click on stacks, that concept is like clearly it's on a pedestal, like on its own place at the top of the docs. Like it's a very first class citizen. So it's a cool way of thinking about it because like this is the final slide I'll show. The other slides don't matter. Like here's a bunch of logos. So like here on the orchestrators section, like there's Metaflow and there's ZenML and there's SageMaker pipelines, there's Kubeflow. Like if you've heard of any MLOps tools, like you'll probably find that tool somewhere on this list. And so you can see like where that tool maps to as an MLOps stack component. And what's cool about this is like if you think about an ML platform as like a stack, as long as you build it right, your components can be swappable. Like, okay, maybe I have ZenML doing a job to be done right now, or like maybe I have SageMaker pipelines fulfilling the offline compute job to be done. Someday, I could swap out SageMaker pipelines for ZenML, or I could swap it out for Metaflow. So like, if you like one thought that I had was like the MLOps space, I think despite what people say, is still super young and turbulent, and tools are changing all the time. And so like I remember when I was architecting the platform for Ben Labs, one of the things that stressed me out the most was like, how am I going to pick tools that we're going to be happy with even 6 months from now? Because like even 6 months from now, the space is so unpredictable. I have no idea what the best online serving tool is going to be, or the best orchestrator tool is going to be. Like there's such a fast race of innovation happening in MLOps right now. It's just we don't know who the winners are, I guess is what I'm saying. So like so if you build your platform with like this stack concept in mind, you can build it so that you don't have to throw away your entire platform just to swap out a single component. Anyway, so
okay, wait, I want to jump that I sort of want to jump in right there. I don't know how that's possible. That doesn't feel like a real thing to me. That feels like something you would say. But that doesn't seem
Yeah.
like I've never heard of that actually. I cannot imagine a company that has built such a perfect abstraction that you can rip out all of ZenML and replace it with Metaflow, and that wouldn't be a 6-month charter project, and anybody would actually allow, like at the company would allow for that project. And this is sort of my point about using something like Modal and Prefect, where Modal is just raw compute and Prefect is just raw orchestration, and like we don't know what tools are going to win in the space, and so like why not keep the stack really 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 simple,
Yeah, like simple
in
and
case things
decoupled is what you're
change.
saying.
Right, simple and decoupled. Like at the end of the day, if you store the data that you trained with and you store the model and you use like MLflow models so that you can start up that model on a Docker image, you don't have to worry about dependencies, and you track that experiment in something like weights and biases or MLflow,
Yep.
and you have the code from the Git SHA that was the way that that pipeline was trained.
Yep.
Yes, there are so many more bells and whistles, but like those are the fundamental primitives to recreate an experiment. It's the input data, it's the code that trained that data, and it's the hyperparameters.
But then
Yep.
when you want to go to production, there's more.
I mean, sort of, like maybe, like
You're
I don't
speaking
know.
like a good data scientist, right? You're saying like all I need is this, these
Let me
things
ask
for
you,
my modeling.
if we deployed a microservice and it was a fast API application and it had a clear Swagger JSON doc, and we had something like LogRocket or Sentry or whatever, capturing the
Hmm.
log, the input and output logs, and we knew when it went down, and we got alerts when it went down, and we had CPU and memory thresholding, like a forget about ML, regular microservices application, serving anything, some CRUD app connected to your Postgres database. We already have the tools for that. Like they're generic traceability tools. Okay, if
Yep.
you shove in, if that app is now just still a fast API application serving a scikit-learn model, right, which was Dockerized during training with MLflow. So you just spin up that Docker image wrapped in a fast API application, and you have Sentry or LogRocket, et cetera, and you're logging all the requests. The only thing you really need on top of that fundamental baseline is like a tool, which you would probably have also had, a tool that is ingesting those logs back into data in your data lake or data warehouse somewhere such that you can run analytics on it. Like as long as I can get those predictions back into a database and then use something, you can pick an open source tool that doesn't require infrastructure, like Evidently, to do drift detection, or even just like if you're doing that, you're already ahead of 80% of the teams. But or you shove it into Grafana and you have some dashboards with some alerting when the lines change. Like I'm just saying, like I mean, there are very complex cases, and I'm not talking about all cases, but I do feel like I'm talking about 75% of cases where you're just trying to serve predictions and like monitor the existence of those predictions. Eric, challenge that.
No, I won't. I'm just kidding.
Do it.
So, like, okay, let me try to make sure I can say in my own words what I'm challenging. So, you're saying, like, so I just said you should have this idea of a stack because if you have a stack, you can have swappable components, and you're not as locked in. And then you came back and said, well, there's no such thing as a system with no lock in because, like, well, I think that's what you said. There's no such thing as a system with no lock in. Is that right?
Or
If you're using like tools that are sufficiently opinionated like these, I get that within the ZenML ecosystem, you can swap out Lambda for Google Cloud Run and probably also Modal, and you can swap out this secret manager for
Yeah.
this secret manager. But swapping out all of ZenML, like that, that doesn't seem like a real thing that would ever be possible to me. Like it seems like it would be an
Yeah.
enormous lift.
Well, hey, okay, I'm not going to argue that there's no lock-in. Like, absolutely. Like, I actually think it's worth giving. I think it's worth accepting some lock-in in exchange for convenience and like productivity.
Yeah,
And like,
100%, 100%.
let me. So like, I went to the Netflix ML Infra conference last year, and we talked about like how we built our data platform and our ML platform, like from end to end, basically. And like, the story I told on stage was like how we went from like ML platform V1 to ML platform V2. So like in our V1, like you're not meant to look really closely about at these diagrams. It's supposed to communicate complexity, but like some of the things on here is like fast API and AWS ECS and AWS Batch and like Lambda and New Relic, like a whole bunch of tools that we had strung together, like a lot of open source tools. And we were, because we built all this stuff ourselves, like we had templates for the Ben way of doing fast API apps and stuff like that. Like we had so much custom code that we'd written that we were quite locked in to the stack that we'd made. And like eventually we simplified it. We picked two vendors. Like we had Bento Cloud be our serving, and we had Metaflow be like training and batch inference. And like one of the things that happened when we did that was like, I'll show you some code actually. Okay, so here's an Airflow DAG. Like here's an Airflow DAG. It is really complicated. Let's see, can I find it? No.
That's such a funny way to start. Here's Airflow. It's hard.
Yeah. Okay.
Nobody's going to argue with you on that, though.
Yeah, they won't. They won't. That's the point. So like, okay, this deck. Like there's only so much code you can process on a screen on a screen share. So the point is not that you actually read this code, but like, let's start by just scrolling through this file. So all right, this file is almost 500 lines long. Here's like us chaining.
Whoa, they still do that? They still do that with the chaining, with the arrows? I thought that was like...
Who's they? They still support it, or the team who wrote this DAG still does this. Like anyway, so my point here, flashing all this code on the screen in front of you. Oh, here's a great part right here. Like this is a piece of an Airflow DAG where it's actually kicking off a SageMaker training job, and just the thing to notice here is like, look at all this JSON config to like kick off a SageMaker job. Like there's so many settings and choices.
I wish I could show you. I wish I could show you my prefect code to kick off a training job on Modal, because it's 5 lines of code. It's just regular Python code.
That's kind of my point. Just like a lot of these tools that are more specialized for data scientists and do come with some lock-in, like they take what used to be like 100 lines of code and they reduce it down to like 2. And then like, yeah, like technically you're locked in because you're using like the ZenML abstraction for kicking off a compute job, or like the outer bounds abstraction. But it's like, but that abstraction is so thin now. Like by thin, I mean, I guess I don't mean thin as like it exposes the underlying details. I just mean like it's very terse, like condensed. And so like,
I think the big thing is that these tools, the biggest thing they simplified was compute. And compute has been simplified now. Like compute as a generic construct has been simplified. And so these tools have to figure out the other things to simplify. And it turns out that there are other things to simplify, but fundamentally the hardest thing was the compute. The hardest thing was just getting your GPU CUDA kernels to match the drivers that were installed when you spun up that EC2 instance. That has been solved. And so they have to figure out all the metadata stuff to also solve, which is also important. It's just less important and less difficult to do yourself.
I mean, I also will say that that's in a specific persona or instance. You may be at a job at an enterprise where you're dealing directly with the GPU. Like you don't have access to Modal or this easy compute type of thing. And
yeah, but those tools don't work in that case anyway. You can't use ZenML if you're on there's no way you can put ZenML deploys to bare metal systems. Tell me if tell Eric, there's no way, right?
I mean, you just said there's no way ZenML can deploy to bare metal systems. It's like, it can use bare metal systems for sure, but like
it can use bare metal systems, but like Demetrios, what I'm saying is that the thing that was hard was getting the compute. Yeah, if you're on bare metal, you're on bare metal, and that's a hard thing. But none of these tools are making that easier. Like
totally. Yeah, like I'm gonna make a claim now. So like there's Dagster and there's Airflow and there's Prefect. Those were like, in my mind, those are like the big 3 DAG tools if you're a data engineer. Like, yeah. And then my claim is that if you're going to use a DAG tool and you're not a data engineer, it will be easier for you to actually use a DAG tool that was purpose built for data scientists. like with the data scientist in mind. So the big three there, I would say, are Metaflow, ZenML, and Flight. I mean, not really Flight. Like Flight was an open source project that came out like I want to say out of Lyft.
Yeah.
I hope it's Lyft. I hope it's not Uber. Okay, cool. And like came out around the same time as Metaflow. I think Metaflow like grew in popularity faster, but like and now there's like a closed source version called Union AI that's like enterprise SaaS tool. Anyway, so like in the old world, you'd show up at a data science team, and the data engineering team would have gotten there first, and they would have set up some workflow orchestrator, and it was probably Airflow, like because Airflow was like the big DAG tool that had everyone excited, and it was becoming like standard across data engineering teams, and it had its own problems. And I think Dagster and Prefect were like reactions to the usability issues of Airflow. And that was great, but those things still weren't built like specifically for data scientists and almost no one else. And so like it still was hard to like have heterogeneous compute. Like let's say you wanted to have a DAG, and like step 1 of the DAG used 2 GPUs because it was training, and then step 2 of the DAG only used like a single CPU because maybe inference is a lot lighter. Like doing heterogeneous compute across the steps of a DAG was like really difficult with these 3 tools. And so like historically, that's when like everyone was really excited about Metaflow and ZenML and Flight, and you could say SageMaker pipelines too, is they made that a lot easier. Modal has now taken it like a step further, where Modal's like, okay, these are all DAG tools. Like Metaflow is a full-on DAG tool, so is ZenML, and so is Flight. But like, do we really need a full DAG tool to do data science? I think that's where Ben is coming from. Is like Modal just does compute. Like you don't have to have like check out the code for ZenML, for example, or like let's look at Metaflow first. So like, I have a class here. This class is my DAG, and you know, like all the steps of my DAG are these functions, and I have them decorated with step. And like, so if I collapse these functions, I got a bunch of functions with step on top of them, and like that. This is the Metaflow framework to define a DAG. So it's pretty opinionated, and it's got a lot of boilerplate. Like I'm doing this step thing, and I'm doing this function decoration thing. And the same with ZenML. Like ZenML has like a step decorator and a pipeline decorator and stuff. So like I have to learn this whole framework in order to like create this construct called a DAG. Yeah, go ahead.
Is it just the step, or like, cause if it's just the step, I mean, that feels like Prefect in that it's unopinionated, but are there other things like, do those functions that take step have to be very specific, or are they like pretty straightforward?
It's more opinionated than Prefect. So like for example, you have to nest in Metaflow, you have to nest them all inside of a class. Like, so I personally really don't like that. And then like within the step, if you want to define the order of the step, you get a lot of statements like self.next. And if you want to say what happens after this, then you like invoke the next step here.
Oh,
so
interesting.
It's not like it's not like this composition of functions the way Prefect is. It's like, I don't know, it's a lot more frameworky. So so that's the Metaflow framework, and you saw the Airflow framework, like the whole chaining of steps together thing.
Yeah, I mean, to Airflow's defense, not that I'm defending, not that I'm going to sit out here and defend Airflow, but I'm pretty sure this is Airflow 1, and I do think that their Airflow 2 situation is a lot more
Prefect-like.
Decorator first.
It is, and it looks so much better. I will also say it still has a lot of issues, but yes, so like, let's see. And then I should probably at least flash ZenML on screen. ZenML looks a bit closer to, Prefect, where like you have these like functions out here in the global scope, and you put a step decorator on them, and then at the very end you make another function with pipeline, and this like chains all your regular steps together. So it's still different from Prefect. You can't go like you can't nest multiple layers deep. Like I don't think you can have a step call a step, or at least I never did that. I haven't seen examples doing that. I think all you have is like pipelines calling steps, like one level, which like I say that like it's some kind of great limitation. I mean, I think you can do most control flow things I can think of with that. Anyway, so like, but the point is like all these are very frameworky. They're quite opinionated. Like in ZenML, you have to create a pipeline. In Metaflow, you have to create a flow. In Airflow, you have to create a DAG. Like with Modal, you don't have to do that. You can call a single function. You can decorate it, or I think you can pass it in some other interface, and you can kick that one function off to like compute on the cloud. Like, so if you're using Airflow, you can still use Airflow and just not use Airflow for compute, and each of your Airflow steps can just kick off a Modal job. like just a single job. Or like if you're using Prefect, which is, I was saying that Prefect is like a data engineering DAG tool. Like how could a data scientist possibly use it? Well, like if you use Modal, like Prefect or Modal will handle the heterogeneous compute for you. Anyway, so I would just say like, I actually think that can work totally fine. Like I can easily imagine a team being successful using like any DAG tool of their choice or none, and then using Modal or something like it. Like there's a few I feel like I should call out some alternatives to Modal in the call just so people know. Like there's one called Runhouse AI.
Runhouse.
Founder's name is
I haven't
Donnie.
heard that in a while. Yeah, like Fireworks Base 10, Lepton AI. There's quite a few of these.
I think it's good to say that because like I think Modal is the one that people I think are most familiar with, but you know, Modal is like closed source and Runhouse is open source, and so there's I don't know, it's just important to know. I think there's a lot of offerings that do similar things, and one of the reasons I think that's important is because this is a pattern that has clearly got legs. Like I may like DAG tools, but there are many people besides Ben out there who see a future where you just use like one of these like compute kicker offers and that's sufficient for you. So, and I feel like that's especially true in like what's my background? Like my background is SMEs, you know, like right now I work for a company called Pattern. I think we've got like 30-ish people doing data science there. And at Ben Labs, it was like kind of a similar number. And like we had all these data scientists and they were doing like classical ML things. They were doing like click-through rates and like basically regression and classification a lot of the time. I mean, there was like a deep learning project here and there, but it was mostly like data science for advanced analytics. And the result of a lot of our products was like some sort of regression or classification model. And we had a lot of projects and we wanted to do all those projects in a fairly uniform way. And so that's a perfect use case for a platform. Like platforms are for when you have many units of work and you want to like sort of have standards across them. Anyway, and like that's a very different use case to someone who's doing an AI startup. I was talking to this guy who's founding a startup that does live translation of like basketball games. So like there's a basketball game that you're like streaming it live, and there's like a narrator being like, he shoots, he scores, and like that audio gets sent into like translation models to translate that into like Spanish and Portuguese and all these languages, and then they rebroadcast that stream out to like all these people watching it. Like
that's awesome.
That company there, like they're not doing what I've been doing my whole career. Like they're not doing classical data science. They don't have a lot of data scientists who are like serving business stakeholders. Like no, they're building one very specific product, which is like very compute and AI heavy. Like it would make no sense for them to use a DAG tool for what they're doing, but it would make tons of sense for them to use something like Modal, like a very compute only focused tool. So I think what you'd see is like for enterprise MLOps, for DAGs, for enterprise MLOps, I think it makes a lot more sense to get a DAG tool because the opinions that DAG tools put on you, they give you uniformity, they give you like a nice UI and like collaboration features. They help with some of the reproducibility stuff. Like, yeah, they do compute as well, but maybe not in, I'll say like none as flexible a way as like the modals out there. But anyway, and I think Ben would say that team can actually do just fine on like vanilla DAG tool plus modal, and like that's very interesting. So that's the ground where I feel like I'm open to be won over. And then like the furthest end, there is a group who just it doesn't even make sense for them to use a DAG tool at all. Anyway, what do you think, Ben?
Yeah, I don't think I disagree with any of that. I don't actually. I think I mean, any team could be fine using a DAG tool and modal if you have the right engineers on that team. But I definitely like the argument of uniformity. Like when I think about where uniformity is the most important, I actually think it's more on the data transformation side than the ML side. Maybe that's true and maybe it's not. Like I really like the idea of building a system where the data platform is not a data engineer only system. It's actually for data engineers and data scientists. They're all contributing to it. And so that's why I've been digging so deep into SQL Mesh, because they have a lightly opinionated system for building data transformations that check downstream dependencies and tell you when you make breaking changes. Everything has to go through GitHub. The backfill process is really clean. You can only backfill in prod when it gets into GitHub. Like, that system to me is very cool and creates a pretty uniform way of thinking about how data gets transformed. And if you do that, then you end up this is fake, but you end up with a training table. Like, obviously not a training table, but you end up with all of your final transformations, such that I want to build a system where the last mile transformations are as nothing as or as small as possible. Like, I don't want much last mile transformation. A lot of these tools, I think, help you with that a lot, but I think you can also get rid of that if you define a really robust data transformation layer. But that's a thought, and I can do it with a team of 6 that I have, but that's very different than doing it with a team of 50, especially introducing it to a team of 50 that has some other thing that they've been doing for the last 20 years. So it's very different coming from zero. Like, yeah, I'm going to do all the best practices. I'm starting from scratch. I can do whatever I want versus, or what I think are the best practices, versus walking into a team of 25 and saying, all right, you're all doing it this way. Like, what is the lowest hanging fruit to meet you where you currently are and lift you up from where you currently are to what is better with as little change management as possible. So I think it's just wildly team dependent. Yeah, I definitely am right now hyper focused on companies that are like very small AI startups. For very small AI startups, you'd be very hard pressed to convince me that you want to pick a opinionated DAG tool. But for a big company of 25 people, I totally understand the argument for why you'd want to do that.
Wow, it's almost like there's different tools for different jobs. Like, yeah.
I still think there are too many tools. That spreadsheet that you just showed, I don't know how many of those companies have gone out of business at this point, but certainly there were more boxes than there were people using those boxes.
No way. No ways. Not a lot of them have gone out of business. If anything, it's bigger now because you have last night when I was hosting the Shift Left Data conference, we had the dude who created that, and he was talking about how now you have this whole layer for AI. And so you have the AI stack that's coming about with the vector databases and the orchestration there, and with the llama indexes and whatnot. And
I still think you can get away with all of that with just using prefected modal.
Well, yeah, VCs are not going to like that opinion. So hopefully none of them are in the chat right now, because that is a fairly simplistic viewpoint. I'm sure you could get away with a lot when it comes to using prefect and modal. I do think that there's a lot of I wanted to call out what Hamza was saying in the chat earlier when we were talking about how the GPU problem is one piece of it, and he chimed in and said data is also very hard to solve, not just the compute. And you bring that up with SQL Mesh. You say that's why something like a SQL Mesh is great to have too, right? And so I look at it a little bit like, yeah, where's the oh, and this is a great one coming through in the chat too. Like, if you really wanted to, you can get everything done with Kubernetes or just an EC2 instance if you really wanted to. But like, how much do you want to work, right? And so that's
right, but like my response to the data thing, I agree, data is hard, and I definitely that's why I look at SQL Mesh. But I thought about this a lot at Galileo. Like, for a little bit, we were playing around with the idea of building a structured data product. We had our products for unstructured data for fine-tuning models. But we wanted to build one for fine-tuning structured models. The problem with it, and like, Hamza can totally correct me if he has people doing this, but I would be very hard pressed to believe that, or to find a lot of teams who are using ZenML from all the way to the raw data, all the way to the model training. So it's great if ZenML helps you with the last mile of your data transformations. No question, it's very valuable. But if you don't know how you got all of the data that allowed you to do the last mile transformations, it doesn't actually matter. Like, it's like, okay, here you can reproduce your model, which was baked off of last mile transformations of bad fundamental upstream data. But if you don't know how to fix the
Yeah.
bad fundamental upstream data, it doesn't matter, which is why I think about SQL Mesh, which is why I want to see if I can make SQL Mesh be the entire layer where you can run SQL and Python transformations there.
Guys, I just
Man,
realized I gotta jump,
Okay.
but this has been awesome, and we got to keep doing it. This is
we should do
very
a part
valuable.
2. I feel like we
Yeah.
just got started. So
But we have to bring on Hamza so he can tell me.
Yeah, we got to bring him on the stage next time and have him show us where that stacks part is of his docs. And it is such a good one. All right, fellas and folks out there, this has been awesome. I appreciate you all joining us. We will see you later. And we've got some good, there's some great stuff going on in the chat. So if, Ben, there's somebody coming at you in the chat. You got to go over there. I'll see you.
That's okay. Bye.
You're like, I don't
guys.
need to get into a fight right now. So that was awesome. Did we